Hello guys, so today we'll be doing question 268 of LeetCode, missing number. Question is, given an array nums containing n distinct numbers in the range of O and n, return the only number in the range that is missing from the array. For example, the array will have a value from 0 until a certain value, and it will keep incrementing by 1 except for one digit in the array. So example 1, input nums is equal to 301, the output is 2 because n is equal to 3 since there are 3 numbers. So all numbers are in the range 0 to 3. 2 is the missing number in the range, it does not appear in nums. Nums 0, 1, 2 is the explanation, seeing as 2 will be the next number. And since there are 2 numbers, so all numbers are in the range 0 to 2. 2 is the missing number in the range since it does not appear in nums. Okay, example 3, again, same situation. It's an array from 0 to 9 and 8 is missing. So the way we do this is fairly simple. We'll just loop through the array once. We'll get the expected value by counting I plus 1 each time. So we know that this has to be from 0 to 9. So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9. Because 0 we don't have to count, because 0 plus 0 is 0. So count from 1 to 9. And then we'll have a current count counting as well, which is that we'll count each value in the array. So and then we'll get the current count and subtract it from the expected count, and that will return the difference, and the difference will be the number that's missing. So I'll show you what I mean here on the whiteboard. Okay, so as you can see here we have the array. It's from 0 to 5, and as you can see the value we're missing is 4. So the difference value is 4. We're going to loop through the array. We're going to increment the sum by the current value that we get each time in the array, and we increment the expected by I plus 1 each time. So let me show you what we do. We'll set I, which is equal to 0 for now. We're now at 0, so we set sum to 0 and expected to I plus 1. So 0 plus 1 is 1, expected is 1. We now increment I is now 1, we're at 1. So sum is now 0 plus 1, which is 1, and expected is I, which is 1 plus 1, which is 2, and 2 plus 1 is 3, so now expected is 3. 3. Then we increment I again. I is now 2. We are at 2. So we add that to the sum. 1 plus 2 is 3. We're at 3 here. Then expected is 3 plus I plus 1. So 3 plus 2 plus 1 is 6. Set that to 6. Now increment I again. I is 3. We are now at 3. So sum is 3 plus 3, which is 6. And now expected is 6 plus I, which is 9, plus 1, which is 10. So sum is 10. Expected is 10. We now increment I again for the last time, which is 4. We are at 5. So we add 5 to the sum, so that is now 11. And we add I to 10, which is 4, plus 1, that's 15. And now we finish the loop through the array. So these are the values we have, sum and expected. So the expected value was 15, and we have a sum of 11. So if we get 15 and we minus 11, we have 4. That is a difference, and that's the number that's missing. The reason we know this is because we count the expected value for what the array should be is if there was no number missing. We start from 1 because we don't count 0, and then the sum is what we currently have, so we know that the number difference will be the number that we are missing. So I'll show you how to do it in code. So the first thing we do is we create a sum variable, set to 0. We create an expected variable, we'll set that to 0. Then loop through the array, so for the I is equal to 0, so the I is smaller than nums.length, then we increment. Next, we set the sum, we add the current value to the sum, and we add to the expected I and 1, I plus 1. And then we return the expected minus the sum. Let's see if that passes. Okay, that passes, you can see, let's submit. Perfect. As you can see, this is the fastest time complexity with 1 millisecond. And this is the time complexity of On as we're looping through the whole array, and space complexity of O1 as we're only storing constant variables. Thanks for watching.